Alright, so these notes should be on October 26th, unless you did them over the weekend. A little Halloween action going on here for the holiday coming up. First person to message me about what this shirt means, besides the fact that I'm a little bit of a math nerd, what it means mathematically, or, well, it's not really a mathematic. Hopefully you get the idea. Send me a message about what this means, first person, and you get 1 extra credit point on a assignment. You could try sending it to Miss Muko if you're in her class and see Miss Christensen was wearing this shirt. I don't know if she'll give you a point or not, but all right. So we're going to start off with a review of factoring. Remember, factoring, you always look for a GCF first, see if there's a greatest common factor you can factor out, and then always see if you can factor again. Okay, can we factor again? Both of those are question marks. Is there a GCF? Can we factor again? It looks like, just skimming through here, none of these have a GCF, so that's fine. Now, that's going to be Z and Z, because A equals 1, so we don't have to worry about that. This is negative. That means one of these is going to be negative and one of them is going to be positive. Then we take A times C, which in this case is 1 times technically negative 42, so we're looking at factors of negative 42. All that means is we're going to be subtracting the two numbers. So we look at the factors of 42 that we could subtract to give 11. Now if you can spot them right away, that's great. If not, then you just start listing them. So 1 and 42. If I subtract those, I don't get 11. 2 and 21. If I subtract those, I don't get 11. 21 is 3 and 7, so I could rearrange those and I could put the 3 here. I like to go in order if possible here. So I have 2 times 3 times 7, so if I bring the 3 over here and put the 2 with the 7, 2 times 7 is 14, and that's what I'm looking for because 14 minus 3 is 11. I want it to be negative, so I'm going to put the 14 here and I'm going to put the 3 over there. And that is basically it for that one. All right. So we could put a little note on there, what I just said about this. That's negative, so that means they're going to be opposite, the two things here. Okay? Now, this is positive. That means they're going to have the same sign, and the sign is going to be whatever this is. So on this one, it's a little bit different. So I'm going to have, this is x, and because that's negative, this is going to be negative. And this is going to be negative. Okay? Now, another thing we can do, because we see a y squared here on the end, is we could just put those y's in there also. Y times y is y squared. So that's kind of the only difference there. Now we're looking at factors of 12, and because they have the same sign, we're looking at factors of 12 that add up to 7. Now I think we ought to be able to find those without listing them all out, probably. Times tables and stuff. Factors of 12, 2 and 6, no. 3 and 4. 3 and 4 are 7. So that's going to be kind of it there. And we're done again. Factoring is an important skill to have for Algebra 2, so we need to work on that and think about it. Okay. Oh, there's a GCF down here. I just spotted that, but we're not there yet. So let's say, and none of these factored again so far. Now, here's the first one where we have an A does not equal 1. So what you're supposed to do there is you're supposed to turn that into a fraction, 1/6. And then you're supposed to write down 6r and 6r. Now, the reason we need the 1/6 there, it doesn't really make that big of a deal in our answer. But if you think about this, if I multiply 6 times 6, I get 36. And I don't have 36, I only have 6. So 6 times 6 over 6, that is just 6. So that makes these equivalent. That keeps this on the up and up. All right, that's negative. Over here, this is negative. That means these need to be the opposite. All right. Now, A times C here is negative 120. And we need to find factors of 120 that subtract to give 7. Now, it's not going to be the first couple because the gap is too big. It's not going to be 2 and 60 because 60 minus 2 is 58. That's way far away. So we could probably skip down here to like 6 times 20. Okay, so 20 minus 6 is 14. Now we're getting closer to 7. So it probably would have wasted my time to list all of those if I can jump down a ways. Now, 7 doesn't go in there. 8 goes in 15 times, and there it is. Okay, and so that's why I try and go in order so I don't miss any and I can find it. So this is negative, so we want the 15 here and the 8 over here. Now, here we're going to factor out a 2. So that's going to leave us with 3r plus 4. And here we're going to factor out a 3, which is going to leave us with 2r minus 5. Okay, so that is that. Now, here we do have a GCF. There is a z there. So what we can do is we could factor the z out now and rewrite the whole thing over again. So that would look like this. What I would encourage you to do anytime you have a GCF is put that down on the answer line. Because what happens sometimes is students forget, they kind of forget about that, and they just do the work over here, and then they circle their answer, and they lose track that there was a z there, or something there. So I would encourage you, once you factor it out, to put it on the answer line. Now, since a equals 1, I'm just going to put this down here on the answer line as well. So I'm going to have z and z, and everything's positive, so that means these are both going to be positive. Remember, this is positive, so they have to have the same sign, and that's positive, so they're positive. And I need factors of 40 that add up to 13. Again, based on your times tables, you should be able to spot that pretty quickly. So that's going to be 5 and 8. All right, so that's a little bit of review. Now we're going to get into today's lesson. So today's lesson is about the perpendicular bisector of a triangle. A triangle has 3 perpendicular bisectors. They're the segments that bisect the lines, the sides of the triangle. And it could be a line, array, a segment perpendicular to the side of the triangle at the midpoint. So these two are equal, and it's a 90-degree angle. These two are equal 90, these two are equal 90. Okay. Those 3 perpendicular bisectors intersect at a point, and that point is called the circumcenter. So we're going to need to memorize some of this vocabulary. You're going to have a question about that. What is the point called where the perpendicular bisectors intersect? It's called the circumcenter. So you want to make sure that you get that. Concurrent. That's when 3 or more lines, raised segments intersect at the same point. It's called the point of concurrency. So all 6 of these things that are on here intersect at point P. They are concurrent at point P. And P is the point of concurrency of those segments. Okay. Now, when we take this triangle and we do that, the point that they intersect at is equidistant from the vertices, which means we could turn that into a radius and we could draw a circle around the triangle. So there's 2 different ways to describe this. We could say that the triangle ABC, is inscribed in circle P. Okay, inscribed means, scribe means to write. Back in the olden days, scribes were people who wrote stuff down. That was their job, to copy stuff, copy books. You can imagine how long it took to make books if you had to write the whole book out every time you wanted another book. Anyway, so triangle ABC is inscribed, is written inside the circle. The triangle is written inside the circle. Now, the circle P, is circumscribed. Circum means around. So circumnavigate means to go around the world. So the first explorer that was credited going around the world actually died on the trip, but still is the name that's recognized. Anybody know who that explorer was? You're looking it up on the internet right now? Ferdinand Magellan. I think he was killed in around Indonesia or something like that on the trip. But anyway, the circle is circumscribed around, drawn around the triangle ABC. Okay? Circumference. Circumference is around a circle. Okay? All right. your parents asked you what you learned in class today, make sure you're careful about how you say that. Circumscribed. We learned about, yeah, circumscribed. Never mind. It's not important. Okay, we usually have a test question like this on the test. So first of all, it says name and give the coordinates of the point of concurrency of the perpendicular bisectors. So when it says name perpendicular bisectors, you want to start to memorize. That's the circumcenter. Circumcenter. All right. Now, if we put these on here, 1, -2, and label. Always label points when you plot them. And then 1, -4 is right here. That's going to be B. And 7, -4 is going to be right here. So if you have your student ID or a ruler or something handy, it's nice when we can make stuff look good. Why not? All right. So now we need the perpendicular bisectors. Now 2 of them are pretty easy. So here I'm going to bisect BC. So that's right in the middle. And then perpendicular. So I had a horizontal. So perpendicular is going to be vertical. And here AB halfway. That's easy. And that was vertical. So the perpendicular is going to be horizontal. And so we only need 2 of them to find the point. So the point is 4, -3. Now, if you want to, we just did back in, well, not just, we're in chapter 5 now, but back in chapter 3 we talked about perpendicular lines. We talked about the slope was the opposite reciprocal. So if you look at AC, the slope of AC is -1/3. So if we wanted the perpendicular of that, that would be 3. So if we want to go 3 from there, and remember that point should be the same. All 3 perpendicular bisectors should go through that point. So, and you can see it's the midpoint of that side anyway, because it goes down 1/3, down 1/3, so that's in the middle. So that's the third one, but you really can figure it out with just 2 of them. Okay? All right, so we have 1 more today. We have 2 today, and I think we have 2 tomorrow, the next lesson. So it's really important you memorize these 2 today so you don't have to memorize all 4 at the same time. So perpendicular bisectors, circumcenter, PC. Perpendicular bisectors, circumcenter. Now we're going to talk about angle bisectors. Angle bisectors intersect at what's called the incenter. Angle bisectors, incenter. So try to remember those 2 combinations. The angle bisectors of a triangle intersect at a point that is equidistant from the sides. Okay? Running out of colors here. So equidistant from the sides, that would be these purple lines. And so if those are equidistant, then that allows us to, those would be the radius of a circle inside. So if I go back to this, I could do that in purple as well. Those were equidistant from the vertices. Okay, if we want to go back to that page. Okay, so that allows us to fill in some numbers and do some things here. So what segments are congruent? Well, first of all, if you think about those purple ones that we just talked about, that would be all 3 of those. So alphabetically, we could say PT is congruent to PU is congruent to PV. All right. Now we do have some other ones though, because if you notice here, we'd have these 2 triangles, and you can see there's a bunch of perpendiculars there. That's a right angle. That's a right angle. And the radius of a circle will be congruent to itself, so those will be equal. And here we have the reflexive property of segment congruent. So these 2 triangles are congruent. That means these 2 are congruent also. So alphabetically there, the best one actually, let's start on this side, would be TX. So segment TX is congruent to segment VX, and segment TY is congruent to segment UY, and down here, segment UZ is congruent to VZ. So those are all the congruent segments. Now it says find some of these numbers. So PT. PT is right here. So they've given us this is 13 and this is 12. So we can use the Pythagorean theorem. We mentioned that the other day. So if we call this A, those are the legs, we're going to have A squared plus B squared equals C squared. So that's going to be 144. You should know your perfect squares up to 15 squared. 15 squared is 225. 13 squared is 169. 14 squared is 196. You just switch those. So hopefully you know your squares up to 15 squared. So if we subtract that, we're going to get A squared equals 25. So A equals 5. Now technically we're going to get A equals plus or minus 5, but that doesn't really make sense to have a negative 5 for a radius of a circle. So it's just going to be 5. So PT is 5. Then it asks for PV, that's going to be 5 also. And then PU, that's going to be 5 also. And then it asks for UY. UY is going to match that, so that's going to be 12. Okay? Now, let's go back to this for a second. There are some things called Pythagorean triples. And a Pythagorean triple is when the three sides of a right triangle are all whole numbers, all counting numbers. Not whole numbers because you won't have a side of 0. Counting numbers, natural numbers. 1, 2, 3, 4, 5, 6. So, I think we saw one before. Does anybody remember? Are you talking to the screen? Mr. Christensen, it'd be a 3, 4, 5. We had that before, I think. 3, 4, 5. And they're multiples. Okay? So, 6, 8, 10, 30, 40, 50, etc. So that kind of falls underneath that category. And now we just saw another one, 5, 12, 13. And we could, 50, 120, 130. So those happen a lot because people who write math tests and math teachers, we know that those numbers work nicely and that all three sides are natural numbers. And so those numbers are used a lot. So if you recognize them, just make sure that the 5 has to be the hypotenuse. The longest side has to be the hypotenuse. So that'll come in handy for you. Okay, so now if we move down here, we're asked some questions about this, AL. So we're asked for this side right here. Well, here we have a triangle, and this leg is 6, and that leg is 8. So I was just talking about that, 6, 8, 10. And so that reinforces the idea. Look how often those things show up. Now, if you forget that for some reason, then you could call this C, and you could do A squared plus B squared equals C squared, 36 and 64, 100, and then you could get 10 that way. But that's a lot more work than just recognizing that we have a Pythagorean triple. So you should be trying to do the next one, AF. All right, so AF is over here, and that's going to match this because these triangles are going to be similar. So that's going to be 8. FL is a radius of the circle, and so is LE. So those are both going to be 6 as radii of that circle. Okay, so now let's go back to this vocabulary that we learned on the previous page. Inscribed. The circle is inscribed or circumscribed? The circle's inscribed because it's written inside. Inscribed in triangle ABC. And the triangle is circumscribed, drawn around, about, is what they usually say, circle L. All right? Okay, so we started the lesson with some factoring review. We're going to end the lesson with some factoring review. So 1/12, no GCF. So that's going to be 12Z and 12Z. This is negative, which means they need to be opposite of each other. And now A times C, that's going to be negative 72. And so we need two numbers that multiply to give 72, but subtract to give 1. So they need to be one number apart. So hopefully your times tables come back to you pretty quickly. That needs to be 8 and 9. That's negatives. That's going to be 9. That's going to be 8. So if we divide both of these by 4, that's going to be 3z plus 2. And if we divide both of these by 3, that's going to be 4z minus 3. You should be able to multiply these back together to get that. Now the 4 we divided out of here and the 3 we divided out of here, that's 12. And 12 over 12 is 1. And that's where the 1/12 went. It gets canceled out with that other 12 that we factored out. Okay, so when you see 4 terms, usually that's factored by grouping. So we have 2 groups. We're going to put that in a group, put that in a group, and we're going to factor. So we can factor out an r squared out of this group. That's going to leave us with 2r minus 3. Now that tells you that the second one should be the same thing. These should be the same. That also helps you factor this. So that's going to be negative 16. Now, kind of would like to do 2 steps at once, but I'm not going to. But if you see it, you could do it right now. Those of you who don't like writing a lot of work down, if you see what's about to happen, you could just write your answer there and circle it. But for those of you who don't see it, haven't seen it yet, I'm going to write what's left, r squared minus 16. So here's where the again comes in. Can you factor again? Yes, because that should be recognized. We use that a lot. That's the difference of 2 squares. So that's just where you take the square root of the first thing and the square root of the second thing. So r minus 4 and r plus 4. Okay? Bam. Now, last thing, and that is, what's the point of concurrency down here? So I should have put that. Point of concurrency. So we're just reviewing. Currency. Should that be U, not a O. It's because I was stuck over there. I was thinking con. I didn't get to the next point there. Point of concurrency. All right, perpendicular bisectors. Perpendicular bisectors, both consonants. P, perpendicular bisector, C, PC. Okay, so that's the circumcenter. Try to write this down a couple times tonight because next lesson you're going to learn 2 more of these things. And angle bisectors are both vowels. Angle bisectors, in center, AI, artificial intelligence, PC, personal computer. Angle bisectors, in center. Okay, start to memorize those. It's about that time. Have a good day. Get to work on that assignment.